All right. All right, so we're going to be graphing the y equals a times cosine of bx. Okay, let's go ahead and start with cosine like we did yesterday with sine by generating an input-output table. So when x is equal to 0, the cosine of 0 is 1. When x is pi over 6, the cosine of pi over 6, square root of 3 over 2, which is roughly 0.86. When x is pi over 3, cosine of pi over 3 is 1/2. Okay, and when x is pi over 2, cosine of pi over 2 is 0. So here we're in the first quadrant, we're at 0. Now the second quadrant, when x is 2 pi over 3, cosine of 2 pi over 3 is negative 1/2. So cosine is negative in the second quadrant. When x is equal to 5 pi over 6, cosine is negative square root of 3 over 2. And cosine of pi is negative 1. Yes? We could, but we don't need to. When x is equal to 7 pi over 6, cosine of 7 pi over 6, we're in the third quadrant, so cosine is still negative in the third quadrant, so negative square root of 3 over 2. Cosine of 4 pi over 3 is negative 1/2. And the cosine of 3 pi over 2 is 0. That is 4 pi over 3. So next we are at 5 pi over 3 in the fourth quadrant, and cosine is positive 5 pi over 3. Cosine is positive in the fourth quadrant, so that's 1/2. Cosine of 11 pi over 6 is square root of 3 over 2, and cosine of 2 pi is 0. So this will be slightly different than sine. So when we go to graph this, 2 pi is 1. I agree. All right, anything else? All right, so at 0, so I'm just going to label each of these. So 1, this is 1/4, 1/2, 3/4, and I'm going to call this part up here 1. So at cosine of 0, we're at 1. Cosine of pi over 6, we're at about square root of 3 over 2, which is about 0.86. So if we say this is 3/4 or 0.75, so we're about right there, 0.86. Cosine of pi over 3, we're 1/2. And cosine of pi over 2, we're 0. Cosine of 2 pi over 3, we're at negative 1/2. Cosine of 5 pi over 6, we're at about negative 0.86, negative square root of 3 over 2. Cosine of pi, we're at negative 1. 7 pi over 6, we're at negative square root of 3 over 2. 4 pi over 3, we're at negative 1/2. 3 pi over 2, we're at 0. 5 pi over 3, we're at 1/2. 11 pi over 6, we are at about square root of 3 over 2. and at 2 pi we're at 1. So the graph itself, with our smooth curve, looks like this. So here, our graph, we have a maximum value here and a maximum value at the end. So this is the end of one cycle, or one period of cosine of x, 2 pi. We have a minimum value here. We have x-intercepts here and here. So when we think about what we did yesterday with our sine, so we still have the 5 key points. So our cycle goes from 0 to 2 pi. So 0 and 2 pi would be our endpoints of our cycle. And then we have 3 interior points here, but it went from max, x-intercept, min, x-intercept, max. Whereas sine went from x-intercept, max, x-intercept, min, x-intercept. So with the sine you had 3 x-intercepts, whereas with the cosine there were only 2. Now what happens if this were a negative? Y equals negative cosine of x. So if this were negative cosine of x, everything would be reflected over the x-axis. So you wouldn't have a max at the 2 endpoints. You would have a minimum x-intercept, max, x-intercept, minimum. Okay. All right, any questions here? All right. So a lot of what we're doing is going to follow the same process of what we did yesterday with the sine. So now we're going to take a look at graphing the variation of y equals cosine of x, namely y is equal a times cosine of bx. And here we say we're going to let b be greater than 0. So we know our amplitude is the absolute value of a. And our period is still 2 pi divided by b. Okay, so let's take a look at this example. So our example is y is equal to negative 3 times the cosine of pi over 2 times x. So y is equal to negative 3 cosine of pi over 2x. What's our amplitude? So our amplitude is 3. So that means that you're going to have maximum value at 3, minimum value at negative 3. How about our period? Okay, so period is 2 pi over b. So in this case, it's going to be 2 pi divided by pi over 2. I got an answer of 4, so that would be 2 pi times 2 over pi. We put that over 1. Pi goes into itself 1 times. 2 times 2 is 4. So our period is equal to 4. Okay, so a cycle, our period's going to be 4. So a cycle for this particular graph, well, our x1 starts at 0. But our cycle, our quarter steps is the period divided by 4. So 4 divided by 4 is equal to 1. So each of our 5 important points, we're going to add 1. We're going to start at the beginning of our cycle, and we're going to keep adding 1 till we have our 5 points. Yes?
Is the amplitude different from A? Or
It's the same. Okay. So x sub 1 is equal 0. X sub 2 is x sub 1 plus 1. X sub 3 is x sub 2 plus 1. So 1 plus 1 is 2. X sub 4 is x sub 3 plus 1. So we're adding the cyclic point here. 2 plus 1 is 3. And x sub 5, our last important key point there, is going to be x sub 4 plus 1. And x sub 4 plus 1 is 3 plus 1, so that's 4. So we already said our period was 4. So we start at 0, we end at 4. So that is a length of 4. Our quarter points are, you take your period, you divide it by 4. So we start at 0, then we're going to add 1, 1, 1, 1. So that'll give us our key points here. Now, this -3 tells us that we're reflected over the x-axis. So at x equals 0, your graph will start at -3, so you're actually going to have a minimum value. So your 5 key points, so x1 will be a minimum, x2, x-intercept, x3 will be a max, x4, x-intercept, and your 5th point will be a minimum. With the cosine, you're either going to have 2 minimums and a max or 2 maxes and a min. Our minimum value is -3. Our maximum value is +3. So our graph looks like this. Okay, so if we call that point 3, that point -3, and then 1, 2, 3, 4. So we're going to have a minimum value at when x is 0, x-intercept at x equal 1, maximum value at x equal 2, minimum value at x equal 3, x-intercept at x equal 3, and a minimum value at x equal 4. You can just toss that. So our graph does this, connect it with a smooth curve, and then of course it's going to continue along that path. But this is our one cycle between x equals 0 and 4. So our period is between 0 and 4. So this is 1, 2, 3, and 4. Yes? Oh yeah, definitely. Yeah.
So, you know,